Far beyond Earth, orbiting the ringed giant Saturn, lies an icy world with a secret deep beneath its frozen shell. Meet Enceladus, small, cold, and dazzlingly bright. But beneath its frosty crust hides something extraordinary: a subterranean ocean. In 2005, NASA's Cassini spacecraft revealed plumes of water shooting from Enceladus's south pole, changing everything we thought we knew. Those plumes hinted at a global ocean beneath, not frozen solid, but liquid, vast, and possibly teeming with life. But now, scientists believe something even stranger. This ocean might periodically flip over, like a pancake on a skillet. This bizarre behavior is tied to a cosmic dance, an orbital wobble known as libration, triggered by Saturn's gravity. Enceladus doesn't rotate smoothly. It rocks gently back and forth, enough to agitate the entire internal ocean. This persistent motion stirs the ocean, potentially flipping dense material from the bottom up to the surface zone. On Earth, sunlight fuels life in surface waters. But in Enceladus's dark abyss, conditions are very different, and even stranger. If life exists here, it might dwell near hydrothermal vents, feeding on chemical energy instead of light. And when that ocean flips, those life forms, if real, could suddenly be thrust into new environments they've never faced. The implications are profound. This flipping cycle could mix chemicals, nutrients, and life, changing the game for astrobiology. To understand how this works, we need to dive deeper, literally, into Enceladus's buried ocean world. First, picture an ice shell 20 to 30 kilometers thick. It's like Earth's Antarctica, stretched over an entire world. Below that shell lies an ocean potentially over 10 kilometers deep, deeper than Earth's Mariana Trench. This ocean stays liquid thanks to tidal heating, gravitational stress from Saturn that causes interior warmth. As Enceladus orbits, it's pulled and squeezed, generating heat through friction, like warming your hands by rubbing them together. Over time, this heating can churn the ocean, creating gradients in temperature, salinity, and density. And when differences in temperature and density become unstable, the ocean can essentially overturn. On Earth, this process is called thermohaline circulation, essential for distributing life-supporting nutrients across our oceans. But Enceladus may take it to another level, with near-total vertical mixing during each massive flip cycle. These dramatic shifts may not happen often, perhaps once every few thousand years, but their impact could be immense. Imagine a world where oceans occasionally stir their deepest secrets into day, literally flipping from abyss to sunlight zone. Such flips might even be visible, icy fractures flexing, geysers intensifying as deep material breaches the crust. And those plumes? They're our main window into the ocean below, containing clues to what might live beneath. Cassini flew directly through these jets, sampling water, organic molecules, and even grains of salt and silica. That silica? It's a smoking gun, suggesting contact with seafloor vents, just like those that host life on Earth. On Earth, deep-sea vents support entire ecosystems with no sunlight. Could Enceladus host something similar? If life evolved there, it may be adapted to extreme pressure, chemical gradients, and complete darkness. And the ocean flips? They might act like evolutionary resets, rupturing ecosystems, redistributing organisms, or forcing adaptation. From our distant perch, we can only imagine what transformation looks like in Enceladus's hidden seas. The idea of a flipping ocean isn't new. It's been modeled on Earth as well, during ancient climate shifts. Enceladus, though, flips on an internal rhythm, one powered not by seasons, but by cosmic resonance with Saturn. That resonance causes its icy shell to flex, crack, and subtly dance across geological time. This isn't just geology, it's a hint of possibility, an alien ocean world with time-driven chemical evolution. What if deep ocean flips released pockets of ancient, preserved chemistry? Molecules dormant since Enceladus formed. In Earth's oceans, such nutrient surges often trigger plankton blooms. Could alien versions occur light years from home? Flips could seed new zones with organics, allowing life to spread, or perish, in ever-changing niches. Understanding this requires more missions, more sensors, closer orbits, sharper eyes around Enceladus's ever-changing face. NASA and ESA have proposed landers or orbiters, but the challenge is piercing through the ice, into the mystery. Imagine a submersible robot, dropped through a plume, descending into black alien waters for the very first time. It might drift past hydrothermal vents, sample strange microbes, and witness a world unlike any we know. We could map circulation, track overturn cycles, and search for evolutionary hotspots trapped between ice and heat. Like Earth's deep ocean explorers, we would go not to conquer, but to learn what thrives in the darkness. Some models even suggest flipping oceans could generate electric fields, charging the ice shell like a giant battery. This buzz of energy, combined with salts and heat, forms conditions eerily close to what first sparked life on Earth. We may never walk there, but from orbit, drop by drop, we can uncover its story, if we listen closely. Flipping oceans, alien bacteria, cosmic tides. Enceladus is no longer just a moon, it's a living laboratory. In its depths may lie echoes of biology's cosmic beginnings, or perhaps another Genesis story entirely. And every time its ocean flips, a new chapter opens, waiting for us to read it from light years away.